Welcome everybody. I'm Catalin. Nice to meet you all. Today, what I want to talk to you about is Azure IoT Hub and a hands-on with some of the features that this solution offers, and some, maybe if you already know about it, maybe there are some tips and tricks. If you don't, then I'm also going to go explain the basics of this. So, as a prerequisite, you will need a Azure subscription to use this service. This service is only available on the Azure cloud. There's no on-premise solution that I know of. Maybe lately they did something, but as I know, there is no on-premise solution. But you can always create a Azure subscription for free on their website. It has a 30 days trial, and then you can switch to a pay-as-you-go. It has $200 credit, which will expire. Thanks. Which will expire after those 30 days. But there are a lot of free tier services, which one of these is also Azure IoT Hub, that you can use even after the subscription expires. So what is Azure IoT Hub? Or maybe first let's start with what is Azure offering in the IoT sector. So this diagram is a little bit older, but it summarizes all the services that Azure is offering in the IoT space. You have their Azure IoT Hub, Stream Analytics, Event Hub, Web Jobs, Mobile Apps, DocumentDB. As I said, this is a little bit older. Lately, they changed some DocumentDB. For example, they changed it to Cosmos DB, which is something more than DocumentDB. Also, it expanded lately with container services, which can replace the mobile and web apps. But these are basically not all of these services that Azure is offering are very specific to IoT, but they can be used in IoT scenarios like Power BI or Azure Active Directory. But Azure IoT Hub is very specific to IoT Hub scenarios. In this workshop, we will discuss mainly about this, but we will also touch Azure Event Hub, which is somehow related to IoT Hub. Okay, as a use case, I'm going to use an automatic flower watering system. As a disclaimer, I want to tell from the beginning that at the end of this workshop, it will not result something that will automatically wet flowers. I'm using this just to have a context so that the code samples will have a meaning about this. I'm telling this right now from the beginning because when I presented to my colleagues, at the end they wanted to see the watering system, and unfortunately I will not be able to show you the actual watering system now. But yes, so this is our context for this workshop. What is Azure IoT Hub? It's a fully managed service that enables the management and also bidirectional communication of IoT devices and between IoT devices and applications. It features some device management capabilities, provisioning, access control, also message ingestion, message management, so also ingestion, but also cloud to device and cloud to device messaging, not only device to cloud. It has a lot of SDKs that can be used with a lot of programming languages that they can be used with this. It supports some communication protocol, maybe not all of them, but the most popular ones, at least HTTPS, AMQP, and MQTT. It has built-in security, built-in monitoring. It is highly scalable, and as I said in the beginning, it's only available in the cloud, no on-premise solution. The pricing of Azure IoT Hub, it has 4 tiers. The free one, it has each pricing tier has its own limitations. So the free tier has 8,000 messages per day limitation. After that limit, messages sent to IoT Hub will be refused. Then it has S1, S2, and S3 pricing tiers, each with its own 400K, 6 million, and 300 million. But these limitations are per month and actually per day for the messages, and per IoT Hub unit. So basically you can scale it vertically with these on these 3 tiers, but you can also scale it horizontally, adding more IoT Hub units as you need. So basically, let's say you have a requirement to have 1 million messages per day. So you can go with the S2 IoT Hub, but you can also go with 3 IoT Hub, S1 IoT Hub. So you can scale it horizontally and vertically. Let me first show you how it's created, how you create it in the Azure portal. I have a subscription. Just a moment, I've created a subscription for this demo. Oops. This subscription is actually a plain trial subscription that I'm using right now, where I have set up already an IoT Hub, but I can try and create another one. Let me see if I can see through there. This is the one that I'm. So to create a subscription, a service, we search for IoT Hub in the list of services, and I already have one that I'm going to use in the feature demonstrations, but we can try and create another one. And I can also show you how it's created and how the pricing selection works, and also how the vertical and the horizontal scaling works. So here you need to give it a name. Then you select the pricing. Right now the free one is disabled because I already have a free one. So in each subscription you can only have one free. The others have to be paid. They have to live, of course. These 3 are the pricing tiers that I'm talking about. These prices are in euros. What I've showed you are in dollars. So $50, $500, and $5,000, the 3 price ranges. And here you specify how many IoT Hub units you want to create. And these pricings, actually, they can be changed later. So you can go and increase the number. Okay, maybe it doesn't like me. Maybe if I switch to duplicate. Okay. Hopefully it works now. Let me know, because I'm not gonna look at the screen. Let me know if something happens and it breaks. So yeah, as I said, the pricing tier is here and the horizontal scaling here. There are some more configurations that need to be done. The number of partitions. This I will talk later when we touch the event hub part. Of course, the subscription, the resource group. I'm not gonna talk about this right now, and the location, the actual Azure data center. And you hit create, and that's all. You have your IoT Hub up and running. Okay, I already have one created, and we're gonna use this, but that's how I created it. Okay, let's go on. Oh, sorry. So these are the pricing tiers. This is a general overview of the IoT Hub service. It has basically the device APIs, the application APIs, and inside there is an Azure Event Hub, although they don't actually advertise it like that. But it has a compatible Event Hub endpoint where the messages are being ingested from the devices. Then there are per device command queues. These are the queues that are holding the messages that are sent from the cloud to the device. There are more stuff in the IoT Hub, like device twins and jobs and all that, not shown in this diagram. Also identity registry, device management, and provisioning. Okay, so the IoT devices can communicate with IoT Hub directly if they have they can have SDKs for communicating with Azure IoT Hub, or through a gateway, which is another device that will listen to messages and relay them like a proxy to Azure IoT Hub. And of course, the applications that can communicate with Azure IoT Hub. Okay, getting started, how to create. I already showed you how to create an IoT Hub. Storage. Although for actually, I mean, it's not required when you set up the IoT Hub, it's not required to create a storage account. You actually need it to run the IoT Hub because there are some things that need to be stored in storage accounts, like file uploads from devices. Also, event consumers that consume messages need the storage account. So I'm gonna show you how to create a storage account. So from the Azure dashboard, you go to storage accounts. Or directly here, and you hit create. Just a moment. Services, storage. And there are two types of storage accounts, the classic ones and the new ones, or the main ones. The classic ones are for backward compatibility. I would suggest to go with the normal ones. And here what the storage account is basically blob storage. Not only, but this is what we are going to use it for. And here you add it. You give it a name, a unique name, because if not, it will not be validated. This one is already taken. Can you see from back there the text, or should I make it larger? Okay, there are some configurations that need to be set. There are pricing tiers for this one as well. I'm not going to go into details about this one. Yeah, you just create it and we'll use it later. I already have one created for this. So the thing is, I did it already because it takes some time to provision the services. For IoT Hub is about 3 to 5 minutes, and for storage is still maybe faster, but so we don't wait here until the services are provisioned. Okay, let's go on. Configuring the service. How you configure IoT Hub for operations. So I'm going to show you now the Azure dashboard's configuration options, and I will explain some of them. Okay, so we go to this Kodiak's IoT. This is the IoT Hub that I've created, and this has the first page is the overview, where you see the host name of the IoT Hub, some details here like the resource group, the location, the subscription type, ID of the subscription, what here, access, shared access policies. This is the security part where we can, we have already 5, these are basically the credentials, 5 types of credentials that we can use. We can add more, or we can change the existing ones. The idea is that, let me click on this one. This control, this credential, you can control here the rights that it can do on the IoT Hub. Registry read and write means they can add devices, delete devices connected to IoT Hub. Service connect, device connect, these are basically do operations from the backend side or do operations from the device side. So yes, for the demos that I'm going to use the IoT Hub owner, but that's never a good idea because in real life scenarios you want to have the security splitted. You only give devices the device key, you only give the backend applications the key for them. So yeah, this IoT Hub supports this type of granular security management. Okay. Pricing and scaling. This is where you can scale it, scale horizontally and vertically the IoT Hub. Vertically through choosing a pricing tier. For the free ones, you cannot scale it at all. As you see, cannot transition between paid and free tiers. But the normal ones can be scaled up and down. And also here, you scale it horizontally, how many IoT Hub units you want to have. Also, the free one doesn't support only one. Basically, this can be done from the Azure portal. This can be done from Azure CLI, command line interface, but can also be done from automation scripts, or I think that's all. Maybe there are other ways to do it. The scaling part, I mean. Okay. Oh, sorry. Operations monitoring. These, as I said, the IoT Hub comes with built-in monitoring and logging functionalities. The logging functionality actually, the storage of the logs is actually also in an event hub stored. When we talk about event hubs and how we retrieve information from there, keep in mind that also the logs and the monitoring are also stored there. So, of course, another one, but it's you can also retrieve this information from there. There are some other configurations like IP filtering, and let's go to IoT devices. This is basically where you can configure IoT devices, add them, provision them in IoT Hub. So basically let them access the hub and send information there. We'll talk about this a little bit later. How can devices be provisioned so they have access to send and communicate with IoT Hub. Also in the configuration, there are the messaging part where you configure settings for the messaging side, cloud to device communications and device to cloud communications. Here, cloud to device communications is configured from here. Time to leave of the message. These are the those device message queues that you saw in the diagram. Those are configured from here. Maximum delivery count, feedback retention. We'll talk about them when we get to the messaging side, but these are where they are configured. Also, this is where it's configured the messages that are sent from devices to the cloud. This is where the event hub is actually configured. And we'll talk about this when we get to event hub consuming events. Other things that can be configured are routes, but I'm not going to go into details about that. Basically, this is what these routes can be configured to basically send messages also to other services, like directly into blob files or to Azure functions, for example. Basically configure webhooks that the messages can be sent to. Okay, metrics, diagnostics, settings, and other configurations, which I'm not going to go into right now. So, SDKs for devices and for backend services, basically there are C SDK, Node.js, Python, of course .NET and Java. For backend services there are .NET, Java, Node.js, and there are also Python and C. That's the ones. Probably there are more. Let me see. So for the devices side, there are even actual SDKs for specific Intel Edison or Arduino was there somewhere. That can be used directly on those devices. Of course, not all the devices are covered by this SDKs, so there is also NCC SDK which can be modified and built on other devices that don't have specific SDKs for it. For what I'm going to use in the demo are the .NET SDKs. The Java ones are very similar to this. So basically, even the class names are the same and the interfaces are the same. The Node.js are pretty similar. You just import the Azure IoT package, npm package, and most of the features are very similar to what I'm going to show you. Provisioning devices. Basically, to allow devices, to add devices in your hub, to allow them to communicate and to enable communication with them. How can this be done? There are a few ways to do it. Of course, programmatically with the API or SDK. There is also, I don't think I mentioned it, there is also the REST API. So everything that can be done from the SDK also can be done from a REST API. But of course, the SDK makes our lives easier. There is this built-in device management functionality in Azure portal, and that's what I'm going to show you. There is a desktop application, I don't know if there is for Linux something or Mac, Device Explorer, which also enables adding devices, communicating this functionality. And there, these three are that I talked about are all manual things, or programmatically, yeah. But there is also some automatic service, IoT Hub device provisioning service, which is currently in preview. And this service enables us to provision many devices because, okay, the manual stuff you can do with 10, 20, 30. Maybe you can even build a dashboard to configure your own in your application. But to configure, like to provision 1 million devices, it will be kind of hard to do it manually. So that's why there is this service, which is in preview mode right now. It's free, but it won't be for long, which enables device provisioning based on certificates that can be embedded in when the device is manufactured. Certificates like security certificates, CER certificates, I think. I'm not going to touch this, although it's a pretty interesting subject. Yeah, let me show you the other provisioning method. So first one, from the Azure dashboard, you go to Azure IoT devices. There's the list. You can add one. You put a device ID, type of authentication, symmetric key we're going to use, but we can also use a certificate. You either auto-generate the key or enter your own key. Of course, it needs to be base 64. And setting if it's enabled or disabled. Not much. Let me create one. Device one. I'm going to auto-generate the keys and save it. And I've added a device. Here, device one. Okay, now let's do it from programmatically. I'm gonna cheat a little here. I have some already prepared code that I can show you. Of course, this needs to be configured with a connection string. Okay, let me get the connection string from the policies. Is it visible? Everyone can see?
The code, not so much.
Okay, I will. Thank you. I'm going to go to shared access policies and retrieve the connection string for the IoT Hub owner, because I just like the owner. Let's see. And I have a variable here to paste it. It's basically not, it's just a the name of the IoT hub, the name of the access key, and the shared access key, a base64 security string. Okay, and we have here a method to list devices and to create device. And if we go to list devices, okay, we're going to use from the Azure SDK, IoT Hub SDK. I'm using here Microsoft Azure Devices is the package name that can be used from .NET. From Java, I think is the same, and for Node, it's Azure-IoT-device. You can find it easily, the package. Okay, and I'm using for this registry manager component, which I'm initializing with the connection string, and then I'm accessing get devices, and I'm going to print them. Let me build this. Not a device. So list devices. And it printed a list of devices. It printed here the device name and the device key. And if you can see it here, this list of devices, device class from IoT Hub SDK, and it printed here the authentication symmetric key, primary key. There are two keys that can be used, primary and secondary. I'm printing only the primary here, and I'm going to use only the primary, but yeah. Okay. And what about creating a device programmatically? And also there is the option to remove the device. Here we have a code for creating device, still a two-liner code. We create a new device. We read from the console the device ID, so we're going to input it. We create a new device. We set the authentication mechanism as symmetric key. We generate two GUIDs here for primary secondary key, but keep in mind they need to be base 64. So not on any string will work. And same device manager, registry manager, sorry. Add device will add the device. Let's do it now. 2. And put device 2. And we have another device. If we list them again, we have two devices, device 1 and device 2. It's not. It's very simple, as you see. Of course, there are other methods to remove device. As you can see it here. Yeah. Also, we can look into the Azure dashboard portal, and in the list of IoT devices, we should see the two devices here, and delete it from here. This is the delete option. And yeah. Okay, the other part with this Device Explorer desktop app, I'm not going to show you. It's the same thing. It's just basically this is an old thing when they didn't have in the Azure portal, they didn't have the device management functionality to create, delete them directly from the portal. They expose this application that can do it. Okay, device to cloud communication. How can we send messages from devices to cloud? So there are three ways we can send messages. Device to cloud messages, these are the ones that are recommended to use for high frequency. They support all protocols. The message size can be up to 256 kilobytes, but keep in mind that the pricing is per 4 kilobytes. So if you send an 8 kilobyte message from the device to IoT Hub, it will count as 2 messages. Count toward the limit that you have on the unit. Okay, temporary storage. So it can be temporarily stored up to 7 days until it is lost. So basically, there's no permanent storage.
Not even optional?
Not even, there's no way to have permanent storage in Azure IoT Hub for this type of messages. Yes, we will talk about that when we get to Event Hub, because that's where the messages come, and we will talk about how to consume them and of course do something with them, because just because the temporary thing, and usually it's not so there are other options to send messages from device to cloud. Device twins reported properties. The next slide I will talk about device twins and what are these, but here we can update the twins reported properties from the device. These are recommended for medium frequency, and file uploads recommended for low frequency. Basically, these are used for large files. I don't know, maybe the device captures images which cannot be used with the first two. Actually, the twin property has a very low limit, only 8 kilobytes per property, so it's even more restrictive. So in those cases, we can have file uploads from the device, and those are stored in the Azure storage account that also needs to be provisioned. The Azure storage pricing, I didn't mention anything. This is pay per use. So basically, if you create it and you don't store anything in it, you don't pay anything. And if you store something in it, you pay for what you store. Yeah. Okay, let me show you some code. Or first, let me talk about the device twins, and then I'm going to show you some code how to send messages, device to cloud messages, also update the twins properties and work with those. So what are device twins? Device twins are like a representation of the device on Azure IoT Hub. It can be accessed even though the device is offline. The device twin is there and can be accessed. It has a JSON structure, one per device, per registered device. It contains connection state, tags, properties, metadata. The model of updating is optimistic concurrency, and it also has change notifications. So basically, when the backend, let's say, updates a desired property, so this is the diagram. The backend can read tags, can change tags. The device doesn't have access to the tags on the device property. So basically, these are for management. The tags are for management on the backend side. The backend can also read and write desired properties, and can only read reported properties. The device can read the desired properties and can read and write the reported properties. So this mechanism is for synchronizing between device and backend, for example, states, like the device is doing something, firmware update, for example. That is taking some time, and using this two-field mechanism, we can do some synchronization between the backend and device and see the state of it, and I will show you more right now. Also, change notifications. The device can subscribe to changes of the desired properties and can act accordingly. So let's say the backend writes, I want you to start. The device will get the message and it will do something, and then it will change the reported property. So the backend will query reported property and see it's not started yet, it's not started yet, okay. And when it sees that it started, good. Okay, let me show you some code about it. Device simulator. I have some code samples for a device simulator. What I'm using here is this device client component from the Azure SDK. This Azure SDK is Microsoft Azure Devices Client. So the other one was Microsoft Azure Devices. This is Devices Client. Okay. Here, let me configure the IoT Hub hostname here from here. We can copy this. And I have some methods here to first set the device, basically give the device ID and device key. Let's go to this method, which does, what it does is actually waits for the device ID and device key, the security key, builds the connection string, the host name that I've just put, the device ID inputted, and the shared access key, creates this device client object from this connection string, and we'll see there what we can do with it. The next one is how to publish events, send events to cloud. And I have here some low logic about sending a temperature to the cloud, random number. I'm serializing it at JSON, so all the messages that needs to be sent to Azure IoT Hub, they need to be JSON. They are sent as byte array. I'm creating a message here. I'm adding some custom properties. We'll talk about this when we get to the Event Hub consuming side. And I'm calling the send event method to send this message. So I'm going to send something like this. And yeah, let's build this and run it. So let's set the device ID with, let's see, device 1 or device 2. Which one do you want? Whatever. Device 1, and let's get the key. And now we'll get a key from here, because we already have it. 1. Of course, these keys can or will be stored in the actual devices. Now I'm just simulating to send. Okay, and let's publish an event. Okay, the wrong key. Yeah, the wrong key. Sorry. So just a disclaimer, another disclaimer, no exception handling for this code. As you saw already, there's no exception handling. Just the raw code, and if it doesn't work, then it doesn't work. We get that exception. Let's do it again. One device, one. And the key. Good. Hopefully it works. And let's publish an event. Ooh, worked. Okay, we send the temperature to a random number to IoT Hub. We'll see, let me send another one. So we will see when we consume it. We'll leave this open to see those messages and how they look like. Okay, let me tell you also and show you also about the twin. I have here some method that I commented, twin properties, and here in this method I'm creating a property called running config. I'm creating a property, I'm setting a field running state to something. Actually, this is not even needed. I'm setting a field in that property, so basically properties can contain nested objects. And they are JSON, so you will see them how they look like. And I'm updating that reported property from the device side. So I'm having this twin collection, which is the twin object or state object for the twin. And I'm updating this property. Let me build it again. And let me run it again. Okay, device ID. Good. So this is this code ran and set the initial property of the running config to some running state stopped. Let's look at the from Azure dashboard. We can look at the devices and we can also query the device twin and see exactly how the twin looks like. So when you select here the device, you have here device twin. And you can see this is how the twin looks like. So it has the device ID, connection state, some metadata, and the properties. The desired properties, which is nothing yet, and the reported properties, which is this. As you can see, this running config, running state is here, and it stopped because I updated it from the device. For the other device, and you can see some metadata here. Last updated when, and this is basically some history of what happened. The version also. So there are some metadata that can be used to trace what happened and to see the flow. If we go to the other device, there is no desired property, no reported property, because we didn't update it yet. Okay, and let's play with it, and let's see how we can play from the backend to send desired property and how the device can react to change that. Okay, so in the device client, I initialize this property and I also set the desired property update callback. Basically, I set a handler for when a desired property would change. So when a desired property would change, any desired property, a handler will be called, this method that is going to get the desired property and do something with it. What it's doing here, not something very fancy. It gets the current property, it gets the desired property, it's making another object here pending config, and it's setting this desired property there, and it's updating the reporter property. Basically making getting the desired property, putting in another field, pending change, and then it calls this, which will simulate like a restart or like maybe a longer period. I'm having a delay here of 10 seconds. So it does something with that. And then it updates the reported property with that value. So it's taking out of the pending config this running state and it's putting into the reported property running state. So it's changing the state to running or whatever we will give it. And it's setting that pending config to empty and some status to success. And it's updating again the reported property. So please stop me if I'm going too fast or it's not clear, or let's run this. Or this is basically only reacting to whatever backend will send. Let's go to the backend code that will set a desired property, right? Okay, I have here the device manager, which has a read reported properties message and set desired property method. Let's go to this one to set it. We get the device ID. We wait for the input of the running state, and oops.
You reached the limit of messages.
4K. Yes, and okay, back. Good. So how we set a desired property? Pretty simple. We get the twin object. Get twin by device ID returns the twin object. We create a property, a JSON, basically, an anonymous which will transform to a JSON. And we update the twin with this JSON. Pretty straightforward, right? So we update the property, the desired, the running config, and we put the state which we get from the keyboard. And with this JSON structure, we update the twin. Pretty simple, right? Let's see how it works. So here, 6 set desired property. And here we will see if what happens. So 6 device ID, device 1. Running state, test 1. And now if you can see here, the callback has been called. It printed the desired property test 1. It waited for 10 seconds. And then config change complete. So now we should see, if we go to this device, we should see the running state to test in the twin. Let's go. Refresh. There you go. running state. And of course, from the backend, we also can query the reported properties. This is method 5 for device 1. And we are printing the running state. Let me show you how this is done. Pretty simple also. Read reported properties. We call the manager. We create an SQL query. Basically, not an SQL query, but the query language that the device twin property uses is something like an SQL. This is also being valid here. And if you can go here, it's also being valid here. When you query all the devices, it's also like a select. So SQL-like query language. When you go to here, yeah. And there are more places when you can use this. Jobs are one of the things that can be configured in IoT Hub, but I'm not going to cover here, but that also can, works with SQL-like queries. So to query the device twin, we create a query, simple one, where device ID equals whatever we give it. Get next twin, we call this method to fetch the results. And here, just iterating through the device through the device list to print the properties. I'm getting the desired properties here with result. Basically, this is the twin properties and desired. These are the desired properties. There are more than, as you can saw in the JSON, there are more. I'm only interested in the one that I'm using. So, and then I'm printing this here. So as you see, I just print it here. Desired running config is test1, reported is test1. So I didn't change the desired one, it still remained what I've set. So yeah. This is regarding sending messages, setting and reading device twin properties, and yeah. Let's go to the back to the presentation here. So cloud to device message, I showed you how to send them. We'll see how we can consume it. Device twins properties, how to set them, how to read from them, from both the device side and the backend side. File uploads, I'm not going to cover today. It's pretty straightforward. Just send a file and that's all. Okay, cloud to device communication. So how we can send messages from cloud or backend side to devices. So there are these cloud to device messages, which are intended for low frequency. Of course, the device twins desired properties, what I've showed you. You set from the backend a desired property, and the device will handle it. These are intended for medium frequency. These are preserved, so there is permanent storage for these. For the cloud to device messages, they're only retained up to 48 hours, and there's only one way communication. So basically, if the device is not online, a cloud to device message will be received when the device comes up online at connection time, but it will only be retained up to 48 hours. So if it doesn't connect in 48 hours, he lost the message. The twin properties are preserved. So even if the device will come up after a week, he will retrieve the desired property that was set to him. Direct methods, these are intended for high frequency, but they also have limitations, 8 kilobytes per request and 8 kilobytes per response. This is actually two-way communication, so you call a method on the device and you get the response back. But the downside is there's no durability. So if the device is offline, you will not get any reply back, and nowhere it will be stored that the method would be called when the device comes back online. So if the device is online, he will perform the method. If not, no. These cloud-to-device messages are available for all protocols supported by IoT Hub. The twins methods are only on AMQP and MQTT, and also direct methods are over AMQP and MQTT. Now let me show you the cloud-to-device messages and the direct methods. Twins properties I already showed you. Okay. Let me go to the device manager, and here send message. I have a method that will send a cloud-to-device message to a device. Not a big thing also. We read the device ID, create a random number, serialize it as JSON, encode it into byte array, send it to the device ID, and the message. That's all. And on the device side, let's do it like this. But the device is not online. Oh, it is online. So, tree, send message, device ID, and it's not yet configured to receive them. I will show you in a minute. So this is how we send it. Okay. Let's stop this and go to the device code, and let's stop the twin thing, and I have a message here, receive messages. That what it does is creates another task that will listen for messages. You will see that this message that we send and the device was not listening for them. We'll get it when we rebuild this, and so the 48-hour preservation. Okay, so what it does, this code is in an infinite loop, calls the receive method. If it has something, prints it on the console. And complete. So basically there is some two-way communication. When you send a message, you will actually get a complete when the message was being received, but you will not get like a proper response. You will only get that the message was on the backend side, I mean. So it's not like blank, shoot, and hopefully you hit it. You will get an acknowledge from the device when it was, and the device, when this completes the message, an acknowledgement will be sent to IoT Hub, which instead can the backend can also subscribe to get the acknowledgement.
What if the connection does not complete successfully? It starts but does not complete successfully?
it will not be, so some error occurs on the device side, it will not be completed, but that's why I said there's no read feedback. There's only if it's completed or not, so you don't know.
Okay or not.
Yes. So if it's completed, you get an acknowledgement. If not, nothing. Okay, let me build this code and restart it. The device simulator. Set the device to device 1. Ooh, I have the key. Yay. Okay, so I got a message. I got a message from the backend. Let me send another one. 3, device 1. Yes, for 48 hours. Yeah, it's in the per device queue, so it will be kept until it's being delivered for 48 hours. Then lost. Okay, so this, I'm getting the messages. It's being marked as acknowledged, yes. Yes, that complete part of the code, that's what it does. I'm not sure if I don't mark it as complete, will I receive it again? I'm not sure about that, but we can try it. If we have time at the end, let's try it and see. Okay. So this is the cloud to device message. Let's go to invoking direct methods, which is more interesting. Okay. Let's go to the backend code. We have a method here, invoke direct method. Option 4. Again, another random number. And we create a request like this, an anonymous object. And we're gonna invoke the method start water pump. We give it a response time out of 30 seconds. And we set the method invocation payload to this request that they just created. We serialize it as JSON. We set it as the payload of the method, like the request. And we invoke this method, device ID, and this method invocation object, which is a cloud to device method from the SDK. And we wait for the result, and we get the result back. And what we do is we're gonna print the status code and the payload of the result. So nothing complicated, right? We'll see. We'll see. You get the status code, and we'll see on the client code how you can do it. And as a heads up, I'll show you the client code. So the client code here has this method, start water pump, which is set here. No, this is here. I have to rebuild this. So when we set the device, we set the handler for the start water pump method. So this method, set method handler, will set anybody that will call this method, the callback will be routed to this method, and this is what the method does. Receive the request body, print something, deserialize the request body. If you saw in the backend code, I was sending some time, and now I'm returning back some string. Pump was started for X seconds. So start water pump was the method. Okay, and I'm serializing this result as JSON, and I'm gonna send the response back to 100, the status code, similar to the HTTP status codes, and the body of the response. Yeah? So, in the device logic, let's say you have some issues, an operation cannot be completed, you can use both the status code and the body to report the issue or to do something, to have some logic in your backend to retry it or to do other stuff. So basically this is actual two-way communication, yeah, which is straightforward. The backend calls a method on the device responds, does something and then responds. Let's run this code and show you how it works. Okay, first I'm gonna have to stop this. And then restart it. Device 1 key, yay. Okay. So I think we have, let's invoke the method device 1, yay. So what happened? Method was invoked on the device with the body this, as we printed out, and the device responded with status 200, and the body result part was started for 0 seconds. I think 0 was the random number that we generated. Let's do it again. For device 1. Yeah, 1. Now it's 1. So a random number, the device got it and replied to the response. Pop was started for 1 second. It did something. I didn't put the delay here to actually wait for, because maybe it was random, would give me 100 seconds and we're just gonna wait here. Okay. A heads up, like the body of the request and the body of the response should be JSON. If it's not JSON, let me show you what happens. Stop the device. And if I would return not a serialized JSON object, but I would return the actual string. Not. Get bytes from this string instead of the serialized. So I'm returning a pure and simple string. And let's restart it. Set device. Whoa, the key is not there anymore. But it's up there, up here. Okay. Okay. Now let's invoke the method. 4. And you can see the response is 200, is 500, and the body is empty, null. So it cannot. It can only reply with JSON body. And also the request the same, has to be JSON. That. So the direct methods, they don't have anything with the device queue. They only, if the device was not online, then the method would fail. It was the device was not reachable. So they work only with online devices. Let's see actually. Let's stop the device and call the send invoke method. Error. As I said, no error handling, so it crashed. Okay. So this is direct methods and how you send it from the backend, how you handle it in the device. Good. But they are intended for high frequency, so yeah. Let's talk about next. Let's talk about Azure Event Hub, what it is and how we can use it. So it's a highly scalable event processing service, data ingress. It acts as the pipeline for the messages. It comes in very useful when you are trying to implement the event sourcing pattern. It has some really nice features like replay functionality. It's very scalable. It implements the partition consumer model. So as opposed to the queues where you have the competing consumer, where a lot of consumers are competing to extract from the queue, this one has another model, partition consumers, and I'm going to explain how it works. And of course, it has a publish subscribe mechanism to consume events. Basically, the consumers are notified when the messages are available and they are receiving the messages. They don't have to poll. Okay, so supports multiple event publishers and multiple event consumers. This is an overview of Event Hub. You have here in the left side the publishers, in the right side the consumers, and in between the Event Hub. The Event Hub, for ingress of the data, it contains partitions. You can specify how many partitions you want to have when you create the service. When I don't think you remember, but when we created the Event Hub, the IoT Hub, actually it asks us how many partitions, and it was selected 2 or 4. Those are the partitions for the Event Hub ingress service. And it also has consumer groups. So these consumer groups act as separate queues, for example. So each consumer group will get the data from all the partitions. So instead of having a queue, you have a list of queues. How many consumer groups you define, that's how many queues you have to consume and you want to define. And this consumer group, the receivers are connected to the one consumer. So a receiver consumes only from one consumer group. And if you have multiple consumer groups, you will have multiple receivers, each connected to one. But of course, there is also the use case where you have multiple receivers connected to the same consumer group. So you can scale also. This consumer partitioning scheme is actually more performant than the queue model, for obvious reasons, but also it has a higher overhead. So if you have 10 consumer groups, for example, each of them will receive all the messages. So it's a lot of overhead, but it actually scales pretty good, better than any queue system with a competing model. Okay, it supports AMQP, MQTT, HTTPS. When you configure the Azure IoT Hub, it asks you how many units. This is basically also available for Event Hub. So how many units you set on the IoT Hub, That's how many units of event hub you will have. Because per event hub, there's also limitations. Per unit, there's throughput of 1 megabyte per second ingest, and egress is 2 megabytes. So you can input 1 megabyte per second per event hub unit and consume with 2 megabytes per second. Also this hash function, so consumers, publishers can send messages to Event Hub. They can send it to a particular partition. So if my device wants to send it to partition 3, you can specify when you send a message which partition you want to send it. Or you don't want to specify, and you can specify a key for the partition, and it will go into a hash function and will assign you a partition key. Or you can specify no partition and will also go into a round robin function. It will be assigned to a partition to evenly. So basically you can specify a partition, you can specify no partition, and it will be assigned randomly to fill in the partitions, or you can specify a key, so you don't have to know exactly which number of partitions, so you don't involve this logic on the device side to know which partition. Why is this? I will explain next. How's the message body, or how the message is looking like? It's a JSON format. The message, the Event Hub maintains order preservation, message order preservation, so it's a stream of data. It offers replay functionality, and I will explain you how. Retention up to 7 days. Can be any body, can be any serializable JSON serializable format. And the messages can also have custom properties. So not only the body, but that it can have metadata attached to the events. So you don't really need to, maybe you write something in a custom property, and you don't need to deserialize, decode the message and to know what it is. Maybe you pass it to the message as it is undecoded, helps consume the message faster. Okay, how partitioning works, I already explained. So you can send it with a partition ID, with a key, or round robin automatically assign you to a partition to even them. With a key, there is a hash function that will assign you to a partition. So if you send it with the same key, it will go to the same partition. The hash function is just get hash code or whatever. It's always going to be. It's not nothing is overwritten. It's always appended. It's always appended, and it will be consumed. But the message order preservation is very important. So it's like a queue. So it's always gonna give you the messages in the order they've been enqueued.
You said the queues were in the consumer groups or in particular.
Act like queues. They act like queues consumers. So
Partitions are overwritten, but the message is kept in the consumer.
no. So partitions are not overridden. They are being filled up, and when you consume it, they will decrease. So nothing is overridden, unless after 7 days, when, yes, they will be overridden.
But what is the difference then between a queue and a partition? Because the behavior is like a queue, but the format of holding data is perhaps different.
Yes, but it's not necessarily a difference. It's a list of queues. So as I said, the partitions acts each one like a queue.
Yeah.
Acts like a queue.
Is this, at least from my understanding, I can.
Yes.
But what is then the reason that a client could select the partition?
There are many reasons. for example, you would want some consumers to only consume from one partition. Maybe you scale it more. You have some more important data in one partition, and you have some less important data in other partition. They function as topics. For example, in
at the end, now we are coming very close to queue functionality. When
Yes.
I want to have an urgent queue, then I'm sending to the urgent queue. When I have a slow queue, where a lot of messages are in, then I'm scaling like this.
exactly. So the partition
But
stuff,
same functions.
yeah. But what is different is the consumer groups.
Consumer groups.
And the consumer groups, basically, each of them receive the data from all the partitions. So you can have some consumers which are faster. You can have a combination. You know?
The big difference to queue.
Exactly.
Okay.
Yeah. So some of the consumer can consume in their own rhythm. Others have the same view over the data, not the same view, other view on the data. So even if one consumer is very fast and consuming everything, the other consumer group maybe is very slow, and it consumes it in its own rhythm, right? So the data is basically copied to each consumer group. So that's where the overhead comes in. Okay. So this partition consumer with consumer groups, each consumer group has its own view of the data stream. So any consumer that is connected to a consumer group has its own view. It doesn't matter that other consumer group already consumed everything. This guy can continue and in its own rhythm, slowly or faster eat up everything. Okay, from the SDK side, the event processor host is the component that enables us to consume events. And what it does is connects to one consumer group, reads all the data from all the partition. Event Hub pushes the data to him. And also Event Hub handles multiple event processors connected to the same consumer group. And I will show you if you have time. If you connect, let's say, to the same consumer group multiple applications, the message will be sent to each of them, not all the message to each of them, but it will scale like a load balancer. It will do like a load balancer to send it to which one. Okay, let's see some. No, I don't think so. You can consume only, I think you can consume only from one partition. I'm not going to show that, but you cannot prioritize them. I will show you how it works. And maybe that's possible. So I have here a IoT Hub event consumer, which we will need to specify the connections. There are 4 things that we need to configure for this. The Event Hub connection string, and we will take it from these endpoints. I think I should hurry up, right? Events, and these are the Event Hub compatible connection string, and we'll copy it here. We also need the compatible name, which we'll copy here. We need a storage connection string that I was talking about at the beginning. This one is the storage, and the access key is here. Copy it, and we need a container name in the storage that will handle this stuff, that will handle the leases. Now you need to create here in the storage In the containers, you need to create a container, call it however you want. This will hold the consumer stuff. I will show you. First, let me delete everything that's in here. No. Okay. Cannot delete from here. Anyway, I wanted to empty it, but it doesn't really work. And I don't want to delete the whole container. So let me guess this name and configure it here. And what does this code do? Initializes a new event processor host with everything that we have declared here, plus some more. This is the name of the consumer group. So event processor host can only be attached to one consumer group. Of course, you can have multiple applications, each of them hosting this processor, which connect to other consumer groups. Let me show you how you create these consumer groups. IoT, we go to endpoints, we go to here, and you have here a list of consumer groups. And you can add here another consumer group, and you can add as many as you want. I think there are some limits. But you can create them from here, and then you connect to that consumer group. And basically all these consumers that you create, so let's say this is how the replay is being done. So let's say you have a stream of data that's coming. Okay, 2 days you received some data, you consume them already with one consumer group, you did something. What if you want to replay this data? So you create another consumer group, and you create another consumer that will connect to that consumer group, and all the data that it's in the partitions will go automatically to this one as well. So you can re-consume them, the same messages again, of course, in that 7-day period. So this is how replay works. And it's pretty simple to do. Okay, the other event hub connection stick storage and list container. And what it does is, so this new processor host is being started, and you register the event processor class that will handle the data. So you have to implement this interface, event processor, which has 4 methods: close, open, process error, and process event. And you implement each of these with your own code. And then you register this, and that's all. You will start to receive messages on this. So let's start it. Build. We should receive now, we sent 2 messages. We should receive, okay. Event consumer, bin, debug, .NET. Okay. So now we did receive the 2 messages, but we also, you see there are 2 messages that connection was open, because this event hub has 2 partitions. So an instance was created for each partition. So basically, you see there are two messages that open partition. We have here open partition with yellow writing, right? If you would had 10 partitions, each partition would have its own instance that will receive the messages. And we already received the 2 messages that we sent at the beginning. And of course, we can send more. Device 1, and the key is here. And publish event. I should receive it. I really should receive it. Okay, I'm not receiving it yet. Let's stop it. Or there you go. Okay. Let's send another one. There you go. And another one. And now they're coming. Very fast. Okay. So this is how you receive them. And this is how you can also play with them here. Let me start another consumer, and I will show you how they will split each other. One will take one partition, the other will take the other partition. Okay, I will finish right now. Now I'm starting another one, another consumer, and you see this one connected to partition 0, and this one lost partition 0. So they load balance it between them. And now I think I'm only sending to partition 0 the messages, or to partition 1. So now only that guy is getting the messages. This one not getting any message. But I think if we disconnect this, I don't know if this will connect to the other partition as well. Let's try it. This should connect to the second partition also and receive the messages. Hopefully that's what I... Maybe it will do it, but not in this fast. Ah, there you go. It connected to the other partition and received the two messages. So, yeah. Okay, that's all I had, I think.
Thank you very
So
much.
the references, and you can, just a moment, thank you. You can see the codes, the samples, and the presentation is available here if you want to try it out and see how it works.